So let me delete all this. Yeah, so okay. So in today's session we are going to discuss about an organization detail. So that is our first topic, how we gonna understand what are the engineering design organization, right? Okay, so the see, this is a project, your project, right? So there will be two type of project you have. One is called as offshore.
Sir,
Oh, my screen is not visible.
yes, sir.
Just a second, let me share my screen. Okay, entire screen, select, share. I hope now it is sharing. Yeah, is it sharing?
Yes, sir. Yes.
Okay, cool. Okay, what is this? Hide. Let me undo and all. Okay, what is this? Right. Okay, so see, projects, right? Projects.
Yes.
So we have mostly, like, if you're working in an oil and gas sector now, you have two type of projects. One is called as offshore
Yes.
and the other one is called as onshore, right?
Yes, sir.
Okay, so offshore means like you are dealing with FPSO, then you have what is called fixed platform, right? Or you can
Yes,
say
sir.
jack and all those things, right? In
Yes.
onshore you have refineries, correct?
Yes,
You
sir.
have refineries. So let's understand, like, if you want to become a piping designer, what piping designer, what is your role? Okay, so your role is to use the PNID, right? And you have
Yes,
to
sir.
do the modeling, correct?
Yes, correct.
You have to do the modeling as per the PNID. Okay, inside the PNID, what information you are getting? You are getting line information and the equipment, correct? Inside the
Correct.
line you will get information about the piping components plus instrument, correct?
Correct.
And in the equipment you will get the information about the equipment. Okay, for that you have to refer MDS document. What? MDS documents, correct?
Yes.
Understood?
Understand, sir.
Okay, so before starting, what I want to understand you is, okay, so I am talking about offshore now. Okay, what is
Yes.
offshore and how the process is working in offshore and all those information I'm going to discuss you right now. Right?
Okay.
So
Yes.
this is offshore. Okay, so offshore. Okay, so what is happening in offshore? Let us understand that. Okay, so let us assume you have a bucket, correct? You
Yes.
have a bucket. In this bucket, you have three layers, right?
Yeah.
The
Yeah. Right.
bottommost layer is called as water, the middle layer is called as oil, and the third one is called as gas. Okay, this is
Okay.
arranged as per the density. What? Density. As per the density, it is arranged in a sequence. So water has a higher density than oil, than gas, correct? This
Yes.
is
Yes, sir.
this is what your oil well, right? So in
Ah.
the oil well, your natural resources are arranged in this manner. Okay, understood?
Okay.
Now
Understood. Understood.
this well is covered with what? It is covered with sedimentary rocks. What? Sedimentary rocks. So this sedimentary rocks is the one which holds the natural reservoir. And at the top here, you have a rock called as cap rock, right? It is called as cap rock. So cap rock is acting as a bottle cap. Assume it as a bottle, and a
Okay,
bottle,
correct.
yeah, the lower part of the bottle is called as sedimentary rocks, which you have gas, oil, and water, and at the top you have a cap that is called as your cap rock. Okay. Now in offshore, what you will do? Let us take an example of FPSO. This is your ship, right?
Mm.
Let me make a horizontal ship here. So this is your ship, correct? This is your
Yeah.
ship, and this
Yes.
part is having a turret. Okay, turret is in a triangular shape. It is like this, and from here you have a drilling pipe. Okay,
Okay.
and it
Okay.
is called as
Understood.
umbilical tube. It is called as umbilical tube. So it's a flexible pipe which is coming from the turret and which is going to the seabed. Where?
Seabed.
Seabed, right? And below seabed you have your reservoir in this form: gas, oil, and water. Correct?
Yes. Correct.
Okay.
Correct.
So what happened inside this umbilical tube? Inside this umbilical tube, you have a drilling bit. What?
Drilling bit.
Yeah, you have a drilling bit. So which goes inside this tube and give a hole here and create a hole here, right?
Right.
So as this, now you know that it's a depth of more than in kilometers. The depth is in kilometers. Okay.
Uh,
So at the top of this seabed there is a lot of pressure. Okay. So when you dig here, because of heavy pressure, all these mixture, what is gas, oil, and water, all this will come to the surface due to the pressure difference, right? I'm
yes,
not
sir.
going into detailing of what the
Yeah. Yeah.
robotics and
Understand.
do. Yeah, I'm
Understand.
just telling you the
Yeah.
basic of it.
Correct.
Okay.
Basic.
Yeah,
Yes, sir.
so you can understand how this oil and gas industry
Yes, sir.
works,
Yes.
right?
Yes, sir.
Okay,
Yes.
so what happened when it is arranged in this fashion? What happened when you pinch here or when you put a hole here? All of a sudden, due to the pressure, everything will become a mixture of oil, gas, and water.
Okay, sir.
So it is a mixture of everything. Now this mixture will come to the surface here at the turret, this part,
Yes, sir.
right? Now
Right.
from this turret, what happened? There is a pipe rack, right? This
Mm.
pipe rack will transfer all this liquid into a system. System is what? Separation unit.
Yes, sir. Yes.
Separation unit.
You.
Now what happens in this separation unit is this mixture separates this mixture separate gas, oil, and water. Okay. Now what happened in the FPSO? There is a tanks inside this FPSO. So one tank is for gas, one tank is for oil, and another we will store the required amount of water. Remaining water we will dump into the sea.
Yeah. Okay,
Correct?
sir. Correct.
Now,
Correct.
when this FPSO is standing here, okay, in the FPSO, not only the process system is here, you have a accommodation for the staff.
Yes, sir. Yes.
Okay,
Yes.
staff accommodation will be there. Okay, now behind this FPSO, there is one more tanker standing,
Mm.
that is called as offloading tanker. Okay, now what
Okay.
happened? This is a continuous process.
Yes, sir.
This is a
Yes.
continuous
Continuous
process,
process.
and this thing is separating out gas and oil continuously. So at certain
Continuous.
point
Yes.
it has a limit to fill the FPSO. So what
Mm.
happened? You have a empty ship standing behind the FPSO and loading the gas and oil in this
Uh,
empty containers.
yes, sir.
Yeah.
Understand.
Now
Yeah.
this
Yes. Correct.
vessel take the oil or gas, whatever type of vessel it is, it will
Yes, sir.
take the oil to the
Onshore.
onshore.
Yes, sir.
Yeah. So
Yes, sir.
this is what happened in offshore. So in offshore
Yes.
you are only doing the separation.
Yes, sir.
You are
Correct. Yes.
not converting, you are not converting crude
Crude.
into
Yes.
petrol.
Petrol or diesel.
Yeah, okay, you are not
Yes.
going to convert anything
Yeah,
from the
understood.
crude, right?
Yes, sir.
So what is
Basically
happening?
extract. Yes.
Yeah, yeah, tell me.
Basically extract the natural
Yes,
gas or oil, natural resources. From there, we are sending to the separation unit through flow lines. There we separate the oil, gas, water. That separated gas and oil and water stored in separate storage tank, example storage tank. From there, once the tank full, that is offloading to the onshore for further
absolutely.
process of uh, uh, required, for example, petrol, diesel,
Correct,
petrochemical purpose.
correct. Okay, so now you understand what how this offshore thing works out, right?
Yes, sir.
Now,
Yes,
if I say,
yes. Sir, one doubt, sir. Sir,
yeah, ask me.
sir, any difference between the umbilical tube and conductor?
Umbilical tube and conductor. What do you
Uh,
mean by
uh,
conductor?
sir,
What is this conductor?
conductor. It's the annulus casings. The drilling uh, tubes are inside that conductor, sir.
Okay,
That
okay,
annulus
understood.
tubes.
Okay, see what is happening here is, see,
Uh,
like now this is your FPSO, okay. Now in the
yes.
FPSO you have a, now this turret can be inside the FPSO or it can be outside the FPSO,
Outside,
okay,
yes, sir.
depending upon what type of FPSO.
Yes, sir. Yes.
Now from here you have multiple umbilical tubes. Now this
Ah,
tube is a
ah,
flexible tube, and inside this flexible tube you will,
ah,
this will work like this. So this is a tube, and then inside this you have a drilling bit like this, okay, and
okay.
from the
Yes.
sides you are putting the water so that it will not get heated. So this
Okay,
part
sir.
is like filled with water, and this
Okay.
drilling bit will goes inside the umbilical tube, and it will
Yes.
go to the location, and it will start drilling there, okay. Once
Okay.
it is drilled, these things will
Ah,
be pulled out back to the surface,
okay.
and
Okay, sir.
because of the pressure difference, because of the
Yes.
pressure
Pressure difference.
difference,
Yes.
no need to put any pump or something, it will comes
Mm.
automatically to the surface,
Yes, sir. Yes,
right.
sir. Yes.
But now
Yes.
nowadays we have a pumping arrangement on the seabed to control the flow,
Okay.
okay. So we have
Yes.
some automation things or robotics stuff will be there on the seabed, and
Ah,
those things will be taking care of the flow.
yes, sir. Required amount of
Yes,
flow. How
okay,
much we need?
yes,
Yes.
okay. Now once we reach the surface, once we reach onshore,
Yes, sir.
now let's discuss about what is happening in onshore, okay. So for
Yes, sir.
example, I have a plant,
Yes,
okay,
sir.
it's a refinery, okay, and always you will find the refinery near to sea,
Yeah.
okay,
Yes.
so that
Ah,
it will reduce the transportation cost,
transportation. Yes,
okay.
sir. Yes.
So what happen in the onshore, you this side you will have a battery limit, what is called battery limit, right.
Ah,
So this is your pipeline,
yes, sir.
and inside the plant, what is the system, what are the systems you have, that is called as piping,
Ah,
right.
okay.
So what are the
Understood.
system
Yes.
inside the plant, that is called as piping, outside the plant, that is from connecting from onshore to offshore is your
To the
pipeline,
okay, sir.
okay,
Okay, sir.
right. So what is happening inside this is, in this, from this pipeline, the pipes will get inside the plant, and it will store in a tanks, okay,
Okay.
it will store
Okay,
in
sir.
a tank, right.
Thanks.
From
Yes,
this
sir.
tanks it will goes to different units.
Mm.
There are max to max 25 units,
Ah,
okay.
that much.
yeah, when you have a very big refinery,
Uh,
the more number of impurities, okay,
mm. Yes, sir.
impurities. So impurities, the more number of impurities you have, the more number of process unit have. So usually in
Okay.
Gulf countries, the impurity level of oil is too much.
Oh, okay.
So to
Uh,
remove all those impurities, you need
uh,
more process unit.
yeah, okay, sir. Got it, sir.
So that's why in Gulf or in Asia or in India, you have a big refineries. But as
Uh,
compared to Europe, because the oil which you have in Europe has less number of impurities. So
okay,
the
sir.
process
Got it.
plants will reduce. The size of process plant reduces. Right?
Okay.
Okay.
Right,
So
sir.
what is happening here is this is your tank.
Mm.
From this tank, it is going to supply the crude oil to first unit, that is called as CDU.
Okay, sir.
So what is CDU? CDU is called as crude distillation unit.
Okay, sir.
Okay. So in this
Okay,
crude
sir.
distillation unit, you are converting the crude. Now what is crude? Crude is called as C22H125. 22 carbon atoms and 125 hydrogen atoms. Now
Okay, sir.
this carbon atom is seems to be like this, C C C C and so on,
Mm.
22 times C22. Okay, and there is a hydrogen atoms like this,
Mm.
H H and all like this. Okay, so this
Okay, sir.
crude is simply useless.
Okay, sir.
It is useless until and
Uh,
unless you are breaking the crude into
uh,
smaller molecules.
okay, sir.
Okay, so for
Got it.
this breaking purpose, we use two method. One is called as steam cracking and another one is called as thermal cracking. Understood?
Understand, sir.
So one is called as steam cracking and another one is called as thermal cracking. So in the CDU unit, in that column, you are using thermal cracking method. What is happening in that is basically the fundamental of this one is to produce is to give what is to give heat to
Yes.
crude. So when you
Uh,
give heat to crude, this long chain, this is called as long
change.
chain hydrocarbon, right? This is a long
Right.
chain hydrocarbon molecule. When you give heat to it, these molecules will start breaking from their bonds and create a smaller molecule,
Right.
and that is called your petrol,
Diesel.
diesel, kerosene,
Yes.
naphtha, asphalt, bitumen and tar. Correct? So when
Got
you,
it, sir.
yeah, when you give the heat to this long chain hydrocarbon that is called as crude, then it will convert into at different temperature, then this will
Yes.
convert into different byproducts, and these
Yes.
byproducts are called as petrol, diesel, kerosene, naphtha, asphalt, bitumen, tar. Now this cracking is happening in this unit, CDU unit,
CDU. Okay, sir.
right? From this
Right, sir.
CD unit, there are multiple different process unit which is used to which is used to which is used to remove
Uh,
impurities,
okay, sir. Okay.
which is used to remove impurities and another byproducts like conversion of multiple byproducts. Now to provide this thermal cracking, you need multiple different process unit called as like steam turbine unit, right? Steam
Uh,
turbine you required. Then to store this byproducts, you need different units. If it is a gas, then you need a compressed gas storage unit for this plant also, right? Now
yes.
after these multiple unit, now you need a storage unit. What?
Storage.
Storage unit. What is storage unit means? Storage unit means whatever the byproducts means this thing, this petrol, diesel,
Yes.
kerosene, naphtha, asphalt, bitumen, tar, all these will be stored in a storage tank. So you have an area called as byproduct storage tankage area. Okay, suppose you
Okay.
have tanks here, 1 2 3 4 5 6. So one tank is for petrol, one tank is for diesel, one tank is for kerosene, naphtha, asphalt, butane, blah blah things are there. So now when you produce this petrol or diesel from this CDU unit, right, these petrol is still not in use. You cannot use it directly, or you cannot put
Yes, sir.
this
Yes.
petrol into your bike, right?
Yes.
So that
Right.
process is called as blending.
Okay, sir.
Blending means to attain required octane number. Have you seen a petrol? Every petrol has a octane number,
Okay.
right? Octane
Right.
number means the way it start ignite, at what temperature it starts ignite. Okay, so
Okay, sir.
those are the chemical things, but we are not worried about it, but just to understand. Okay,
Yes,
so
sir. Please.
the petrol which is generated from this CDU unit is not pakka. It's not
Yes,
that
sir.
it's not that good to use directly in your bike. So what they do
Yes.
is they send this petrol in the storage tank, and from this storage tank it will goes to a blending station.
Okay, sir.
It will goes to a blending
Blend.
station, and from in the blending station they will add the
Ah,
additives into the
okay, sir.
petrol to attain or to achieve the required octane number.
Okay.
Yeah,
Okay.
and
Yes. Yes.
from this blending station it will goes to the final
Storage.
storage tanks, and from this storage tank it will goes to the gantry area, gantry gantry area, and from this gantry area it will goes to supply or market.
Okay, sir.
Understood? Now,
Understood, sir.
to support all these units, to support all this process unit, you need a utility unit.
Yes, sir.
Okay, now what do you mean by utility? Okay, so utility stands for steam, air, nitrogen, water. Okay, yeah, steam, air, nitrogen, water, right? So these all are your utility. So for steam you need a steam generation unit, for air
Yes.
you need a air compressor unit, for nitrogen you need a nitrogen plant, and for water you need a water station. Correct? Now this
Correct, sir.
this water this water has multiple use.
Yes.
Like for fire water you will use,
Yes.
normal water purpose you will use, and some treated water. So for this
Ah,
treated water, then you have, now regarding this water you need a cooling tower.
yes, sir.
This cooling tower will support the steam generation unit plus the water unit also,
Okay,
right?
sir.
So this is
Right.
how your onshore work. Now if I compare this, okay, now, okay, right, okay, now if I compare this offshore and onshore, if I compare both the projects, so first of all, if I say the lifespan means project lifespan, so the offshore will be finished in 1 to 1.5 year maximum.
Okay, sir.
The onshore project will stay for 1 to 3 years.
Okay. Okay.
Onshore project. Now if I talking about the job opportunity, so in offshore less number of people required, but in onshore you have more number of people required. Understood?
Understood.
Regarding the complexity, so offshore is more complex due to space constraint, right?
Yes, sir.
In terms of onshore, less complex because you have lot of space
More
to
space.
play.
Yes.
Correct?
Yes. Correct.
Offshore, if you go to offshore, salary wise, offshore is more because of the complexity, and in onshore it's similar but little less to offshore, right?
Right.
Little less to offshore. Understood?
Understood, sir.
Okay, now regarding the process units, so if I talking about process unit, so offshore has less process units, right? Only the separation unit is a major unit, and remaining is all utilities. But in onshore you have more number of process units. So what is the benefit of that? Exposure,
Ah,
exposure,
yes,
experience, right? But priority is for offshore. Priority is for offshore. If you have in your CV, if you have an offshore experience, they will consider you more
yes,
on as compared to onshore because of the
yes,
complexity, because of the congested piping, right? Stress
right.
critical lines are more, and the stress lines are very difficult to route and reroute and modify.
Analyze.
Okay, because you don't have space. So that's
Yes.
why in your experience or in your CV, at least one project is required. If you have at least one project is more than enough to get any job. Okay,
Uh,
understood?
Understood.
Any doubt till here?
No, sir. Understood the process of offshore and onshore.
Good, right.
Yes, sir.
Now
Before I
hmm,
aware about how the offshore works. In this class, I know how the process of onshore is work in a refinery process. How the refineries are work. Basic
okay.
CD unit from that cracking
So
is
there are a
happening.
lot of lot of because see, main is your CDU, main is your
Yes, sir.
CDU,
It's a initial.
okay,
Yes, sir.
and all remaining all the units are called as supporting unit,
Yes, sir. Yes, sir. As you
right?
tell
Yeah,
before,
all are supporting units.
impurities. Yes,
Hmm. Okay, now let's come to the departments. Okay, how these things work and how our company works and how the project works. Okay, so see, your project has four phase. Okay, so first one is called as 30%, second one is called as 60%, third one is called as 90%, the third and the fourth one is called the remaining 10%. So in the 30% of the project, see, being a piping designer, you will be in the project or you will get the job when the project starts. So when the project starts, as a piping designer, you will get the job and you will remain in the project till the project finish. Okay, no doubt the number of employee will be reduced, but there will be a piping designer job, right? But if you are stress engineer, your job starts after 60% review till 90% review. So as a stress engineer, you have a very short lifespan, or as a material engineer you will be there till from the starting, but you will survive till the 60%, because till 60% material engineer jobs is almost done because everything is finalized, PNID is finalized, PMS is finalized, everything is finalized. But the piping designer stay from start to the end. Okay, so to
okay.
get into this field you have to start your career as a piping designer. That will be very easy for you to get into this field. Okay,
Yes,
right? Okay, in the 30% model, in the 30% project status, what are the things that you are going to cover it? So suppose if the project is at 30%, it means equipment equipment layout is final, right? And major piping is done. Okay, if it is 60% model review, means all piping done except below 2 inch.
uh,
Yeah.
yes, sir.
So in the 60% now, what is happening? All the piping is finished except below 2 inch, and stress analysis start, right?
Yes, sir.
So the stress engineer start his works from here till 90%. And now what is happening in 90%? All the piping, all piping plus instrumentation plus stress comment updated. right? And
Yes.
ISO is started to release. Now what is happening in this 30%? When a project starts, the client pay 30% of the total amount of the project.
Oh,
In the
okay.
60% he will pay the next 30, and in the 90% he will pay the next 30% of the amount. Sorry. Right?
Yes.
Now remaining 10% he will kept with himself.
Mm-hmm. Okay, sir.
Why? Because of the as-built drawing.
Uh,
Right? Because of the
yes.
as-built drawing. The more number of as-built drawing you produces, the amount will be deducted from there. Okay?
Okay, sir. Okay, sir.
So this is how the project will work. Right? Now let's come to the disciplines. Okay. So in the project, the maximum amount, that is your 75%, is covered by piping. So that's why piping has most number of people in the on the job. Okay, the
Okay,
remaining
sir.
will be structural, electrical, instrumentation, and if you want more, then you have some architectural and HVAC guy. Okay, right? and and
Right.
and the major portion, like, you can say like it come with the piping only. So piping, process, and you can say material, and you can say stress, everything will consist of this 75% of the job. Correct?
Correct,
Now,
sir. Yes.
being a piping person, so if I'm talking about the departments, if I'm talking about the departments, so we have piping, then you have a structural, then you have a structural or civil, then you have a process, then you have a electrical, then you have your instrumentation, then you have your HVAC. This will come on the offshore only, because in onshore you don't have that much of HVAC work. And then
Mm.
architecture, that is also in offshore. Okay, so this
Okay.
this this will comes in your like what do you say, accommodation part and all those things. Then you will have this architecture and HVAC job. Okay,
Okay, sir.
so
Okay.
remaining, this is the main core departments you have. Okay, now
Okay, sir.
this piping is giving information to structural, this piping is giving information or taking information from process, and this piping is giving information to electrical, and this piping is giving information to instrument, and similarly to HVAC and architecture also. Right? So
Yes.
the maximum number of man hours is spent on piping. Okay, the
Okay,
maximum
sir.
number of man hours is spent on the piping. Now what is happening here is, now because of that, we have a large opportunity of job. Okay,
Okay,
we
sir.
have a large opportunity of job. Okay, so for example, if you are staying in a company, if you are staying in a company where the project just started, so you have a lifespan of 3 years. You have a lifespan of 3 years in that project, in that company. So if you want to grow now, so every 3 years you have to switch.
Okay, sir.
If you stay in a company for more than 3 years now, your growth will
Ah,
be certain.
understand.
Okay, so every
Okay.
3 years you have to switch the company for your own personal growth,
Understand, sir.
until and unless in this 3 years or after the 3 years they promote you to a different designation.
Mm, mm. Got it, sir.
If they are not promoting you for a different designation, for example, if you started as a designer
Yes, sir.
and if they make you engineer, then it's okay.
Mm,
If they make you designer to senior designer na, it is better
mm.
to switch and apply for senior designer post in different company.
What company? Understand, sir.
So what will happen in that way? You will get the position plus you will get the money.
Yes, sir.
Understood?
Understood.
Any doubt here till now?
No, sir. No.
Okay, good. So this is how this what do you say, whole system works, right?
Okay. Yes, sir.
Okay. Go and pick it from downstairs. I will tell you something. I will tell you something. Now come to the next topic. That is called as your input to piping. Okay.
Okay, sir.
What are the input that is getting to the piping department? Okay. So the topic is now here, from here we are coming to the syllabus. Okay. So input to
Right.
piping. Please make sure now you just make a note of all this. Okay. Okay, so the first point, that the first information that you will get as an input to the piping discipline, that is called as PFD. Okay, what is this
Okay.
PFD? Any
Process flow diagrams.
correct? So it is called as process flow diagram. Okay, so there are more words called PFD, then PNID, and before this PFD there is called as BFD,
Yes, sir.
and it is called as block flow diagram, and this is called as piping and instrumentation diagram. Okay, right? So
Right, sir.
BFD, PFD, then PNID. So these are on the stages. First we will create the BFD, then we will create the PFD, and then we will have a PNID. So if I simplify this BFD, what do you mean by BFD? BFD means block flow diagram. So what is
Yes.
happening? It is mainly related to your onshore. So there is a plant. Okay, and now in this plant, you know that there will be a tankage area. Then
Yes,
from
sir.
this tankage area there will be another area called as CDU. Then from this CDU unit there will be another area called as like a HGU, hydrogen generation unit. Or from this CDU you will have any another unit called as utility unit. Or from this hydrogen generation unit you will have some another unit called as like your steam turbine is connected. Then this some steam turbine there will be a cooling tower, and from this CDU unit you will have another called as byproduct storage tank, and from this the blending station, from this blending station you will have a final product storage tank, and this from this final product storage tank it is going for a transport of gantry area, right? So
Ah,
this flow is called as block flow diagram.
understand, sir.
Understood?
Yes,
So
sir.
this block flow diagram is on the basis of maximum, what? Maximum number of pipe going from one area to another area. Understand? So
Understand, sir.
accordingly they will locate the units next to each other. For example, if this is a CD unit, okay, and from
Yes.
CD unit, for example, there are 200 lines, okay, 100 line is going to another unit called as RFCC,
Ah, okay, sir.
okay, and 50 line is going to a utility area, 150,
Okay.
and then you can say there is one more unit, 20 line is going to HGU, hydrogen generation unit, okay, and there one more 20-30 lines is going to another unit, okay. So
Okay.
if you know that there is 100 pipe which is going from CDU to RFC, you will always keep RFCC unit next to the CDU unit,
Ah, yes, sir.
correct?
Correct.
Because
Correct,
in the
sir.
layout,
Yes.
first of all you have to identify the location of units.
Yes, sir.
Okay, so this
Correct, sir.
BDF consists of location
Ah,
location of process units.
units. Understand, sir.
Understand?
Understand.
Similarly, now what is in the PFD? PFD means inside a process unit, let us say inside a CDU unit, this is a CDU unit. Now you have equipments. So
Yes,
this
sir.
is your pipe rack inside the CDU unit. Now you have a column here, you have one more column here, you have a heat exchanger here, you have a pump here, okay, you have a air coolers this side. So from this equipment to this equipment, okay, or you can say from this column, what could be the next equipment which will be near to the this column. You understand my point?
Understand, sir.
So how you will come to know from the number of lines. Suppose
Ah,
from this column you have 20 lines which is going to this second column. So you will
yes.
keep this second column next to this column.
Near to. Yes, sir. Yes, sir.
So inside unit, which equipment comes to which equipment, near to which equipment, that you are going to decide in this PFD.
Yes, sir. Understand.
Understand?
Understand, sir. Understand.
So that is how you are going to create a PFD.
Yes, sir.
Got it?
Got it, sir.
Now in the PNID, what are you going to identify? So PNID will gives you the exact number of
Line.
lines with with instrument connection.
Yes.
Understand?
Understand.
So this will give you the actual idea of how much lines, what type of equipments, what are the spec of equipments, what are the size of
Nice.
equipments, every detail, each and every detail, and what are the instrument as linked to that piping,
Yes.
everything will be given in the PNID. Understand?
Understand, sir.
So this is the first input to the piping.
Typing. Yes.
Okay. Now let's
Okay.
come to the second input to the piping. Okay.
Okay, sir.
Now second input to the piping is called as instrument and cable tray width on pipe rack. Understand? Okay,
Understand.
so in the pipe rack, the instrument and the electrical guys, they have to give you the tray width.
Yes, sir.
Okay, so that
Yes.
suppose this is your pipe rack. In
Uh,
this pipe rack at the corner always we will place the
yes.
instrument tray. So they had to
Yes.
tell you that what is the width of the instrument tray and how many instrument trays they are going to plant. Accordingly we will lay down our pipe on the another corner and we will keep a clear distance.
Distance. Okay, sir.
Okay,
Understand.
so that
Okay.
information has to be given to the piping team.
Yes,
Third position, third point, that is called as equipment data sheet. What?
Yes, sir. Equipment data
Equipment
sheet.
data sheet, right? Equipment
Right.
data sheet means like for creating any equipment you need a data sheet,
Yes, sir.
and that data sheet consists of the length, width or dia of the length, or you can say height. So height and length, width and dia of the equipment, so that we can cover, we can block the space for the equipment. Because
Yes, sir.
if you don't block the space for the equipment in future, if something moves here and there, then it will be a problem to the layout.
Okay, sir.
Right? Now,
Yes, sir.
the fourth input that we needed as a piping guy, we needed from another discipline is called as anchor bolt drawing. Now, this anchor bolt drawing is related to pump,
Okay, sir.
right? So, this
Ah,
information also we needed when you are going to create a pump. So, you needed this anchor bolt drawing, because if this anchor bolt drawing will be wrong, then the pump will not be installed properly in the on the site.
yes.
Okay.
So this input from mechanical
Yes, it's some from a see. I'm saying it. Whatever the input is
inputs.
getting to piping from different discipline. It can be process, pipe,
Yes, sir.
structural,
Yes. Understand.
electrical, mechanical, whatever. Okay.
Yes, sir. Yes,
We
sir.
need information, right?
Yes, sir. Yes, sir.
Without this information, we can't start our work. Okay.
Yes, sir.
Now the
Yes.
fifth point is called as civil information.
Mm.
Civil information. Now what are the information we can get from the, that is called as the location of the What?
Sir, pipe rack.
Yes, the
Yes.
foundation location. Okay,
Yes.
so that
Foundation.
information we needed from the civil. And
Yes, sir.
apart from this, piping
Yes.
will give input to civil that where
Yes.
we needed a support.
Yes, sir.
Okay,
Correct, sir.
that is output from piping.
Ah,
Okay,
yes, sir. Correct,
okay.
sir. Understood.
Sixth point. Sixth point is called as your, if any vendor drawing is there, okay, or vendor package, mainly vendor package. Sometimes what happen, like they have a diesel pump package, or some
Ah,
compressor package. So if they
yes.
have any packages in the
Yes, sir.
project, so they have to give us the package information. So that is called as your
Vendor.
vendor package. Now, in this vendor package, what is important for us is the battery limit location. So they have a time here. See, suppose they have a
Yes.
nozzle or piping, whatever. So this information, this battery limit information is required for us to connect our pipe with the vendor equipment or whatever the arrangement they have. Right. So this thing
Right.
is called as tying point.
Yes.
This thing is called as tie
Times.
in point. Right. Correct. So we
Correct.
basically we need a coordinates. Okay, in real life situation, what happens if you don't have a vendor? So what we will do is we will route our pipe and we will put a flange and we will finish our pipe here like this,
Yes,
right?
sir. Yes.
And when the
Yes.
vendor package came, so we will match it with the,
Ah,
yeah, then we will connect it with the vendor.
correct, sir.
Correct. Or we
Correct.
will we will create a dummy and we will create a dummy nozzle and then we'll create our pipe like that and we'll connect our pipe. Okay, so that's a
Okay.
dummy thing, right?
Yes.
Now the seventh point is mainly for the offshore, that is called as your architectural drawing. Architectural drawing, mainly this one is for the living quarters and all those things. So those architectural drawing, again this architectural drawing, what are the use for us is like we are going to connect the utility lines, like the mainly the water lines, and the
Yes,
HVAC
sir.
duct and all those. So for that also we need a tying point, right?
Yes.
Because we are not going to create an architectural building for them. It will be
Yes, sir.
created by a different group. They will
Yes.
just send up their model and we'll merge that model into our E3D and we'll just connect our piping. Especially is the water piping only, water and fire water piping. So we will connect it with them. So but yeah, we need a architectural drawing so that our tying points should be fixed.
Okay.
Correct. Now the next
Correct.
one is called, the eighth one is called as instrument hookup drawing. Now this is the most important drawings, yeah, very much important. This one, and then this one, and then civil information, anchor bolt. Okay, vendor package will come after 60%. When the project is finished, then only the vendor package will come, because we don't touch those lines till we have the information. We don't have the information, yeah. And then instrument, and the most important is called as instrument hookup drawing. Now this instrument hookup drawing will give you the actual detail of how the, for example, there is a pipe. Okay, now this is an OLED,
Yes, sir.
right? This is an OLED. So from this OLED in the PNID, it will show like this, PI,
Yes, sir. Yeah, yeah.
right?
Yes.
But in instrument hookup drawing, it will show you like this. There is a connect pipe nipple, then will be a flange, then there will be a T, then there will be a reducer, and then there will be a nipple, and then there will be a pressure indicator, then there will be a needle valve, and then there will be a plug. So
Yes, sir.
PNID is showing only you the 3 by 4 inch OLED and then the pressure instrument. But
Yes,
in
sir.
instrument hookup drawing, how this PI is connected to the pipe is actually shown in the instrument hookup drawing. So
Yes, sir.
what is missing in the PNID? It's
The
missing the
detail.
components. So
Yes, sir.
see this nipple, reducer, T,
Yes, sir.
needle valve, plug, and then there is one more isolation valve and then one more nipple, right? Or you can say a
Right.
pipe piece of 100 mm. So this much
Yes.
of MTO is missing from the PNID, right? So
Right.
in case of instrument, in this is called as inline instrument. What is called inline instrument? So this
Yes.
inline instrument MTO is totally dependent on the instrument hookup drawing,
Yes, sir.
right?
Right, sir.
Okay. Now the last one is a 9 point. That is okay. This is if you don't have it, then still okay. But just for your information, just telling that is your called as HVAC layout. Okay,
Okay.
especially works for a offshore project because you have HVAC items and all those things. So you like ducting and all those things you have in your offshore project. So that HVAC ducting layout will be there. Now for this HVAC, now the openings are important. Okay, so for that purpose, because opening means like the way they routed their HVAC duct, it should not clash with your piping.
Piping. Yes, sir. Yes,
Yeah,
understood.
so for that
Yes.
purpose we need HVAC ducting layout. Understood? So these are
Understood.
the information that is required for piping to start their work. Understood?
Understood. Yes, sir.
Any doubt till here?
No, sir. Clearly
Okay.
understood.
Now let's come to the next point that is called as output from piping. Okay, output
Okay.
from piping. So heading is output from piping. Okay, so what are the output from piping? The first and most important output is called as plot plan.
Got-
Okay, the first and most
Yes.
important output is plot plan, and that can be your overall plot plan. Okay, so this
Okay.
overall plot plan does not show any piping.
Yes, sir.
No piping.
Yes.
Okay, it will show only the what? Only
It,
the
it,
unit boundaries plus
not
equipment if
making.
if it is a major equipment.
Yes,
Okay, some big columns or something like that, then only it will show there are columns,
sir.
reactors and heaters. Okay,
Okay.
so this is the overall plot plan. We will cover this overall plot plan, how to create a overall plot plan, what are the information we needed to create a overall plan. We will discuss in the next session. Okay,
Okay, sir.
second thing is called as PMS. PMS means piping material specification, or you can say piping material class, whatever you wish to say. But
Okay.
depends on from company to company, this words change. Okay, so this PMS will give you the information about the spec used in
Yes.
project. Okay, as is like in the sample price you have a spec called A1A, A1A, B1A, then F1C and all those spec. So every project or every company created their own naming philosophy for the specs. So if you ask me about this A1A, what does it mean A1A? So A stands for 150 rating, one stands for sorry, not A stands for this carbon steel, one
Okay.
stands for 150 rating, and the
Okay, sir.
another A stands for no, it's not like this, sorry. Wait. Yeah, so this A stands for 150 rating. Okay, this one stands for corrosion allowance, and this A stands for material.
Okay. Okay, sir.
Right, so A is for 150, B is for 300,
Got-
C is for 400, D is
Okay.
for 600, and then E is for 900, F is for 1500, and G is for 2500. Right, these are the ratings. Okay, so corrosion allowance is one is a corrosion allowance and A is the material. So if A stands for carbon steel, okay, if it is here, if it is S, so it will be stainless steel, depends. Okay,
Okay.
so in my project, like I have a spec called as like uh AD20, something like that. Okay,
Okay.
so
Okay.
every alphabet has their own meaning.
Okay, sir.
Right, so every alphabet has their own meaning, so maybe every project has their own nomenclatures, naming philosophy for every project,
Yes.
right?
Got.
So this PMS, now who create this PMS? So if it is a big company, then it will be your material engineer. If it is
Yes.
a small firm company, then it will be your piping engineer.
Yes. Yes, sir. Yes.
Okay, okay,
Okay.
so this is the second output from our end. Third output will be your equipment layout. Equipment layout. Now what is the difference between the plot plan or the overall plot plan and the equipment layout? In overall plot plan, you will have a whole project area,
Uh,
full project. But in equipment
yes,
layout, you will, in this full project, you have the multiple units. So
yes, sir.
equipment layout is for these units,
Okay,
or
sir. Particular.
you can say this as unit
Yes.
plot plan.
Okay.
Okay, unit plot plan. One is called as overall plot plan, which consists of all the units, and equipment layout is also called as unit plot plan, which means inside a unit how the equipments are arranged.
Yes, sir. Got it.
Got it?
Got it.
Okay. Now let's move on to the next output, that is called as the pipe rack layout, or you can say the arrangement of the pipe rack. So the fourth point is called as arrangement of pipe rack. Now, what do you mean by arrangement of pipe rack? The pipe rack arrangement means the tiers,
Yes, sir. How many?
how many tiers,
Yes.
and the width of the pipe rack.
Yes.
So, generally, the lower tier is called as your process tier,
Process plan.
and the above tier is called as utility tier, and above utility there is a flare line,
Okay, sir.
and instrument, right?
Yes, sir.
Now the width of the pipe rack is totally depend upon the number of lines going from the pipe rack.
Okay, sir.
So generally the pipe rack width can be 6 meter, 8 meter, 12 meter, and 24 meter. Okay, if it is 24 meter, then you have to make two pipe rack of 12 meter and 12 meter. You
Oh,
cannot
okay.
make a stretch of 24-meter pipe rack. Okay,
Okay.
so it
Okay.
will be a 12 meter by 12 meter, right? So it will be a two
Right.
pipe. I will show you the example of this also.
Ah,
A 24-meter pipe rack I have in my project, so I will show you that also, right?
okay,
Okay,
sir.
so general arrangement of pipe rack means the number of tier, the width of the pipe rack, and the total length or the flow of the pipe rack. Means pipe rack starts from here, then it will goes to this side, then there will be a baby pipe rack, or you can say the branches, and then this pipe rack is connected to the unit, and inside the unit there is one more pipe rack. So this
Okay.
is called main pipe rack. This is called main pipeline. This is called sub pipeline. Sub. Okay, substitute, or you can say the branch
I
of the
understand.
main pipeline. Okay,
Okay.
right. So fourth point is your arrangement of pipeline. That is the output from our end. The next one will be your civil information drawing. Now civil information drawing, or you can say the support layout. I can say the support
So,
layout. Support layout means on the pipe you have to provide a support.
yes.
So this location, now the support can be of two types. Two type means a combination of two type. One is called your primary support plus
Yes.
secondary support.
Yes.
Okay, so primary support is like the support which is connected with the pipe and resting on the secondary support. Secondary support is the support which is holding the weight of pipe and primary support and resting on the grade. So
Yes,
you
sir.
have to
Understand.
provide the location of this support so that the civil foundation can be made.
Yes, sir.
Correct?
Correct. Correct.
Sixth point is called as your piping layout. Piping layout. So totally to or piping plot plan, also you can say piping plot plan, you can say, है ना? So we have one is called as overall, second one is called as equipment layout,
Okay. Yes, sir.
and the third one is called as piping layout. So
Yes.
difference is overall means it will consist of the whole plant, second equipment layout means inside the unit,
Unit.
and the piping means combination of equipment layout plus piping.
Okay, sir.
Means suppose this is your unit plot plan. In this unit plot plan, when you are making a equipment layout, you are only showing the equipments
Yes, sir.
and the pipe rack. You understand my point? But
Yes, sir.
in the
Yes.
piping layout, you will show the connected pipe also.
Yes, sir.
So
Correct.
you got my point? You will
Yes,
show
sir.
the connected pipe also. So the only difference in piping layout is you are showing the piping in the equipment layout. Okay.
Okay, sir.
Nowadays this is very means like it is generated in onshore only. Okay, It is generated in onshore, and that too on offside. What? Offside. See, in onshore there are what do you call it? Two area. One is called as offside, and the another one is called as unit. Offside means what is happening in offside means tanks area, pipe rack, and your gantry, and your steam area, steam turbines, and your cooling tower, right? And your cooling tower. So this all comes as offside.
Okay.
And another area is called it is not area basically. See, when I was working in an onshore project, it was one of the biggest refinery. When it is going to be finished, it will become the world's biggest refinery. It is still, the work is still going on. Means I started that work in 2013 and it is 2025. So it is still going on, that work. Yeah. So I worked in that plant. I work on the offside. Offside means I was doing the piping of these tanks, pipe racks, gantry, and all this.
Okay,
And
sir.
another is called as unit piping. Yeah, yeah. It is called as offside piping, and another one is called as unit piping. So unit piping means inside a unit you have the
Okay, sir.
equipments and pipe rack and all those things. Then you are doing the unit. You are doing the routing. Correct.
Understand.
And
Okay,
another
sir.
one is called your tanks, pipe racks. So
Thanks.
their routing is called as offside
Uh,
piping. Okay.
yeah.
This is
Okay,
too
sir.
boring. This is very boring because the only straight line everywhere is straight line only. So there is no much work to do it. But in this area, in this area, you have to generate piping layout, right? In
Okay.
this area you have to generate piping layout, but for unit piping you will not generate piping layout. You will only generate equipment layout, because in this area, in this offside area, the maximum size of pipe is 72 inch.
Okay.
So you have to generate the GAD, general arrangement drawings, and the construction will be done on the basis of GAD, not on the basis of isometric.
Oh,
In the
yes.
unit piping, you are generating isometric of
Okay.
each and every pipe, correct?
Okay.
But in the
Correct.
offside piping, you have GAD for the fabrication, because these big pipes, if you generate an isometric, if you generate an isometric, see this there is okay. I will show you. Wait. It's very good, very interesting thing this one.
Sir, due to the pipe size,
No, due to the pipe length.
length.
See, what is happening here is this is your plant,
Yes.
right? And this is your tank storage area. So from this tank storage area, you are lying down the pipe. Then you are lying down the pipe. Then from here it will go like this. Then here, like this. It is traveling the whole area like this, like this, like this. It's like this, okay? And it is
Okay.
coming out. So what is happening? So this is like 15 kilometers, 20 kilometers, 10 kilometers, 20 kilometers. You understand? So
Understand.
15-kilometer pipe isometric, there is no point of generating isometric, na?
Understand, sir. Like
So that,
pipeline, what you
yes. So that's why they create GAD.
understand, sir.
And on that GAD, you will mention each and everything, the pipe name, the size
All
of
in
the
this.
pipe, the
Okay, sir.
support location, the sleeper location, blah blah things you will generate. So easy, it is easy for the fabric, it is easier for the fabrication.
Okay, sir.
Understand? And no need to
Understand.
generate for, see, if you create a GAD, you will have, if you have 10 lines, in one GAD you can show all the 10 lines. But if you want to extract isometric, you have to individually, you have to extract 10 isometric, and it will be increase the cost of the product project.
Correct.
Correct?
Correct.
So you
Understand.
understand what I'm trying to say?
Understand. Sir, yes, sir.
Hmm.
Sir, what, in the unit area,
Yeah.
you don't generate GAD only isometrics.
No, 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 we generate GAD, but
Ah,
we don't
ah,
generate piping GAD. We generate equipment GAD.
aha, okay, okay,
Okay, that is the difference between equipment layout and piping layout. Piping
okay, sir.
layout, you will add piping also in the equipment layout.
Okay, so my doubt is,
Hmm.
in future, some as-built work
Hmm.
will happen inside unit area.
Hmm.
At that time, how they, what drawing they will refer to
Isometric.
isometric only. They
Yeah,
will
yeah.
refer GAD in that they
No, no,
will.
no. They don't refer GAD. See, again, I'm saying
Uh, okay,
equipment layout. Equipment layout only you show equipments,
yeah,
and
understand.
you generate isometric for each line, right? For
Yes,
each line inside the unit. But
yeah, yes,
on the
yes.
off side, on the off side, you generate GAD.
Only GAD. Yes,
Yes,
no isometric.
no
Yes.
isometric.
Okay, so in the outside area for construction we refer GAD.
Yes,
Inside unit plan we
we
refer
refer
isometric.
isometric. Correct.
Okay, sir. Okay. This
Understand?
detail I don't know. I thought in every for every unit or every we first we need to generate a GAD, then uh, we need to generate isometric one.
Correct. Okay.
Okay. Yes,
Okay.
sir.
Now
Okay, sir.
let's move on to the next input from output from the piping department, and that is your called as and that is called as what is the number? I think sixth or seventh. I guess sixth. Okay, let us say six. So the next input is output from our side
Okay.
is called as nozzle
Orientation.
orientation drawing. Correct. So this
Correct,
nozzle
sir.
orientation drawing is very important for the
Yes.
vertical equipment.
Okay, okay, sir.
Okay, you never see any nozzle orientation drawing for horizontal equipment, especially for vessel and drum. Always you will see the no, vertical equipment like your column, heater, reactor, whichever is vertical, na, you will give the
Uh,
nozzle orientation drawing.
okay, okay,
Okay,
sir.
because in vertical equipment, what is happening here, you have a nozzle at an angle.
Okay,
You
sir.
have nozzles at angles. So for that purpose, you have to give a nozzle orientation drawing.
Okay,
Okay.
sir. Okay,
Now,
sir.
because of this also, the seventh point is called as the vessel cleat location drawing DWG. Now, what is vessel cleat location? Because of this nozzle at an angle, the pipe which is going, which is connecting to this, the pipe which is connecting to this also in the angle, and this pipe has a support from this column surface,
Yes. Yes, sir.
right?
Understand. Yes, sir. Yes,
So
yes.
now this column, when the support is taken from the column, you have to give the information of that support location, because they had to create, like for example, this is your column in a front view elevation.
Okay, sir.
Okay, now this is your nozzle and the pipe is going from here like this, so
Yes.
you will put a support here.
Okay, sir.
So
Okay,
this
sir. Then take
support, yeah, yeah, this is called as clit. This
okay.
raised part is called as clit. So you have to give the information of the clit so that the vendor of the column will provide the clit at this location. So you just have to put your support here and you have to bolt it.
Okay, sir.
So this
Understand.
vessel clit information is very, 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 very important in
Okay,
output
sir.
piping from piping.
Okay, sir.
Understand?
Understand.
Now the eighth point is called as simply your isometric. Okay, isometric,
Okay.
you have to generate isometric for each and every line in the unit area, and then because of that only they are going to create the fabrication. They are going to
Yes, sir.
do the fabrication as per the isometric. Now the last
Okay.
point is called as the MTO. MTO is called as material take off.
Okay.
Understand? Material
Understand.
takeoff. Now material takeoff will happen in three phases. Okay, one is called as initial MTO, second one is called as intermediate MTO, and the third one is called as final MTO. So initial MTO will be taken when the 30% model review is done. Intermediate will be taken when the 60% model review is done, and the final MTO will be taken when the 90% model is done. Okay. In the
Okay, sir.
initial MTO, you will create the MTO manually.
Uh,
Manually means with the help of P and
P and
ID.
ID. Yes, sir. Okay, sir.
Understand? So you
Yes,
have
sir.
to
Yes,
create the MTO
yes,
manually.
sir.
Once the
Yes, sir.
60% is done, then you can use E3D to extract the
Okay, sir.
MTO.
Okay, sir. Okay.
Okay, even for the final MTO, you can use the E3D.
Okay, sir.
Understand?
Understand, understand.
So this is all about the inputs to piping and output from piping.
Yes.
Any doubt till here?
No, no, sir. No, sir.
Okay. So that's it for today. Next we will
Okay, sir.
discuss in the next session. Yeah.
Okay, sir. Sir, can you